Tēnā koutou katoa. Welcome to this Techweek panel on MethaneSAT. Thank you very much to Pūnaha Ātea, Auckland Space Institute, for hosting this event. And welcome to everyone in the room and joining us online. While space activity, space research in New Zealand, in Aotearoa has a long history, for the New Zealand Space Agency, we really are only 6 years old, fairly young. And in that time, in that short period of time, we've seen so much happen. I can still remember around 5 years ago when we were huddled around the screens, waiting in anticipation of some of the early Rocket Lab launches. So, for instance, it's a test and just testing and business time in the early launches, and that real sense of excitement. I think for me, some of that sense and some of the butterflies in the stomach came back when watching the other day of the first stage recovery as it was coming down under parachute and being caught by the helicopter. And certainly in a few weeks' time, we're going to see something truly awesome with the launch from New Zealand of the capstone mission, really a monumental event where a payload from New Zealand is being launched to the moon. And when we look across the space sector, we see so much happening from launch, but also spacecraft manufacturing, ground station operations, space situational awareness and Earth observation, data analytics. It really is quite exciting. We see the establishment here of the Institute, bringing in a world-class team and impressive facilities. We've got the Kiwi Space Radar, Leo Labs Kiwi Space Radar, established in central Otago. The development of Zera Starboard Maritime Intelligence Platform, the test flights of Dawn's Aurora Mark II and the Kia Atmos, and so much else happening. And I know I will offend some people by leaving them out, but I just want to give you a sense of the scope and scale of activity that we're now seeing happening in New Zealand. And within the New Zealand Space Agency and the wider Ministry of Business Innovation and Employment, of which we are a part, we've had a number of exciting initiatives over the last few years. So for instance, we have had our first few sets of NASA interns with really positive feedback, both from the interns and from NASA. And we've managed to continue some of those internships online while everything was being shut down, travel being shut down during COVID. I'm just going to pause here and acknowledge the work of my colleague Eamon Fraser, it's his last day today in the Space Agency. He's moving off to another job in MBIE, and he's done a tremendous job on the internships. And while we love all our interns, I do want to do also a special shout out to Andrew Alder, who's recently gone over to Rocket Lab, but has spent a bit of time working with us in the past. So apart from the internships program, we've had a really exciting space technology partnership with the German Aerospace Centre, with DLR, looking at synthetic aperture radar, optical communications, and in-space propulsion, and that is going extremely well. Our collaboration in the Rongoai project with the Cygnus mission with NASA and US universities, the Taki Waihere Geospatial Hackathon that we ran last year in conjunction with MaxR Technologies, a partnership with Leo Labs and a number of other companies. And I think one of our flagship initiatives, and the one that's very, very dear to my heart, is this one here, MethaneSAT, and the partnership with the Environmental Defence Fund in the MethaneSAT mission. I think it's fair to say that Kiwis like to do things differently, and if you look at the growth of our space sector, which in many ways has been led by commercial activity, it's very different from what you see elsewhere in the world. And in a similar vein, our approach to what we call our first official space mission collaboration also has some unique features. So for instance, here we have partnered with an environmental non-government organisation in this early mission investment. For the New Zealand government, there's a few things a few objectives for us. Firstly, it's a practical contribution towards a global problem. This week the government announced its emission reduction plan around how New Zealand is going to make its fair share contribution towards tackling the problem of climate change. But of course we're active internationally as well, through the UNFCCC and also through our scientific contributions. And the very ambitious goals of MethaneSAT, which you'll hear about today, give us a chance to buy into some of these solutions. It's also an opportunity to get our scientists connected to frontier research in atmospheric science and working with remote sensing data from satellites. And importantly, it's an investment in our space sector capability. I've talked about some of the breadth of activity going on here, and obviously mission operations is a critical part of space capability, and through MethaneSAT, this is something that we can contribute to and grow in New Zealand. So I'm lucky today to be joined by a very high caliber panel. I think online you will have seen some of their bios, so I won't go into that, but I'll do quick introductions. But they can give you some deeper insights into how this mission, into the mission and how New Zealand is contributing to it. So I'd like to kick off by asking Dr. Sara Mikaloff-Fletcher, who's a principal scientist of atmospheric chemistry and analysis at NIWA, and also the team leader of the New Zealand MethaneSAT research team, to kick off with a brief overview of her role in MethaneSAT.
Kia ora. Thank you for that lovely introduction, Dimitri. So I'm the lead for New Zealand's science project for the MethaneSAT satellite. What does that mean and how does that fit with the overall global mission? So the core mission of the satellite, what it was designed to do, was to be able to detect emissions of methane from fossil fuels from space. So this mostly looks like big blowouts from oil and gas production and transport. But the satellite is going to be among the first with the capability to be able to also detect another type of emission that's very dear to our hearts here in Aotearoa, New Zealand, which is agricultural emissions of methane. So the science team in the US is responsible for developing all of the science tools and infrastructure to take that measurement that you get from the satellite, which is really a measurement of light, of infrared radiation reflected back from the Earth, right through to a concentration of methane in the atmosphere, how much methane there is in the atmosphere over a certain area, and then through to what you actually really need if you want to do policy or emissions reduction, which is actually to know what the emissions are. And then there's quite a lot of atmospheric modeling and development of that modeling along that pathway. And there's a spectacularly good team in the US working on that from Harvard and Smithsonian Astrophysical Observatory. And we are partnering with that team to develop all the tools that might be needed and test them, that might be different for agricultural emissions. One of the best things about getting a role like this is that you get to put together a team of really smart people who are incredibly fun to work with. So I'd like to acknowledge my colleagues working on the program from NIWA, which is also where I'm based, but also from University of Auckland, from Manaki Whenua Land Care Research, from GNS Science, and from University of Waikato. So our task is to develop both the global targeting strategy for the satellite. So this isn't a satellite that will observe every spot on Earth. It's a satellite that will observe about 30 targets per day. And so the strategy of what parts of the Earth we need to observe to be able to get agricultural emissions and where the satellite can do the most good. And then the second scope is to develop those tools to be able to take those observations of infrared radiation and translate them to maps of emissions over specific areas. In some ways, that's quite similar to the fossil fuels work, so we're really excited to be able to work with and build on all of the tools developed in the US. But in some ways, it's quite different, special, and harder, because fossil fuel emissions of methane tend to be big point sources that form clear plumes, much easier to observe from space. Agricultural emissions, especially agricultural emissions like we do it in New Zealand, are much more diffuse. So those tools need to be adapted. And our work also includes a really comprehensive field campaign to be able to validate those emissions estimates. While there are many groups in the world who are trying to use satellite measurements to be able to pinpoint fossil fuel emissions of methane, there are very few, no one's ever been able to do agricultural emissions at the type of very fine spatial resolution that we are aiming to achieve in this project. So in order to prove a first in the world capability, you have to really show that you've done the job. So we also have a field campaign to measure methane concentrations from the ground, in the air column, with aircraft, and from flux measurements, from any covariance flux measurements that measure the fluxes locally. Thank you very much.
Thank you very much, Sarah. I'll next like to turn to Dr. Peter Vedder, who is beaming in from the US for this panel. Peter is the Senior Director for Mission Systems in MethaneSAT LLC. It's a not-for-profit company established by EDF. So Peter, could you tell us a little bit about our partner in this mission, EDF and MLLC? Peter, did you hear that?
Thank you, Dimitri. Can you hear me?
Yes, I can hear you. Can you hear me?
All right. Well, on behalf of EDF and the MethaneSAT team, it's a pleasure to be participating in this week's New Zealand Techweek panel on MethaneSAT. I work for MethaneSAT LLC, which is a subsidiary of the U.S. Environmental Defense Fund, who originated the MethaneSAT mission. Beginning in 2012, EDF started a series of studies looking at methane and trying to see if it was a contributor to global warming. Methane has roughly 80 times the warming power of carbon dioxide over the first 20 years after it's released. So it's an important factor in global warming. To measure methane globally, though, we need a global perspective, and really one that can only be achieved from space. And so therefore the idea for MethaneSAT was born. MethaneSAT really is an audacious program. The idea that a nonprofit, even one as well established as EDF, could build and operate a satellite seemed preposterous at the time. Equally audacious was the goal we set for ourselves, which is to reduce oil and gas methane emissions by 45% by the year 2025. The good news is, though, we're well on our way. EDF has raised all the needed funding through philanthropies, foundations, and individual donors. The spacecraft and the instrument are currently being assembled and tested in Colorado and getting prepared for launch in early 2023. So my role is to oversee the development and the readiness of all the pieces on the ground, the software, the communications antennas, the facilities, the people that will eventually operate the spacecraft after launch and to process the flood of data we'll receive. So this includes things like being prepared to receive the data transmitted from the ground to various ground antennas, delivery of that data over the internet to our mission operations software, the operations teams who will then check it and monitor the health of the spacecraft, send commands to task it for the next observations, and also process the data that we receive to deliver the products that we can turn into action, as Sarah just described. The spacecraft needs to be remotely operated, so we have to plan ahead and be prepared for anything that might occur. And so to do that, we've really built an exceptional team of people, both here in the US and in New Zealand. Tom Ingersoll was one of our program leads, has already started and led several successful space companies. On our advisory board, we have Joe Rothenberg, the former head of NASA's Goddard Space Flight Center, Dr. Charles Alachi, the former head of JPL, and leading our science team is Professor Stephen Woofsey at Harvard, one of the world's experts in trace gas emission detection. And having New Zealand join as a partner, as Dimitri outlined earlier, was a significant achievement to really bring worldwide engagement into the program. So I've got the good fortune to collaborate closely with the groups at MBIE, Rocket Lab, University of Auckland, and NIWA to get us ready for launch, to make sure that we're going to be able to deliver the information we need to drive global warming down, as well as the exceptional people at Ball, Harvard, and here in MethaneSAT LLC. Just want to highlight that MethaneSAT truly is a global program. Not only do we have strong partnerships with our teammates in New Zealand, we're using ground antennas from a Norwegian company scattered across the globe, including one in Awarua down there in New Zealand. We're going to be making global observations of methane and freely distributing the data to anybody who might need it. And in the end, making a global impact on climate change for future generations. So thank you. Look forward to the discussion and questions.
Thank you very much, Peter. I'll next turn to Leigh, who's a Senior Program Manager at Rocket Lab and the Program Lead for Rocket Lab's work on MethaneSAT. Leigh, can you just give us a quick overview of Rocket Lab?
We started off with launch. Genesis behind this New Zealand space industry was really Rocket Lab and Peter Beck's vision to make space more accessible. And so we've started with launch, but here we are talking about a satellite that's not built by Rocket Lab and is not launched by Rocket Lab. But we're going to be operating the satellite. So what is operating a satellite? Well, really, when you look on this board behind us and you can see the ISS there, you can see how its inclination is pushing it around the globe. And when we talk global, we're talking about a ubiquitous asset that is able to be tasked to look around the globe to look for these methane emissions. And so you've got the sexy asset in space that's doing some really cool spectrometry, and we need to get that data down, right? And so we talked about Peter mentioned Norwegian company. So Rocket Lab's managing the contract with the Norwegian company KSAT, which requires a whole bunch of ground contacts during the day to get a whole bunch of data off. So the data that Sara wants at the end of the day needs to get down to the Earth somehow. So that's the link segment. So we've got the space segment. We've got a link segment, which is based through KSAT and the ability to transmit commands to the satellite and get health data, telemetry down from the satellite, and also a whole bunch of data. We're talking petabytes of data per year getting off the spacecraft down and then into the hands of the science community and publicly available, like Peter touched on, to provide some amazing data so that, one, we can understand what it's doing to the globe, but secondly, we can understand where these emissions are being made from, and potentially, target these companies, nation states, individuals to resolve these potentially inadvertent emissions from oil and gas. And if you don't know you're leaking, you don't know you're leaking. And so if someone can point that out, then you can do something about it. And I guess methane can be used for profit, right? You can capture methane if you are inadvertently leaking it, and you can turn that into a business idea. So it's something that's really easily well, not easily, but simply to find, but you need to get that data down and you need to operate a satellite. And so Rocket Lab's role in this mission is really to operate this spacecraft. So we will be tasking the satellite, getting telemetry down from the satellite, running the Mission Operations Center. But more importantly, and probably a nice segue into Chris, is that we are establishing what mission operations in the cloud looks like from a New Zealand context. So on behalf of MB, reporting to MB in terms of the New Zealand aspect. And then working with smart people like Peter mentioned, and Peter himself, he didn't mention himself, but a great resource there to deliver a product and deliver a mission operations centre that is world-class and world-leading. And then we obviously go through a training and certification mechanism to hand over to the University of Auckland. So that's where Rocket Lab sits. We're the integrator, we're the prime implementing entity as part of this program, and obviously partnering with civil government and academia to bring this capability to New Zealand.
Thank you, perfectly. And Chris, just turn to you. Can you provide us a bit of an introduction to University of Auckland's role in this mission?
Yeah, sure. So the University of Auckland has recently set up a space institute here in the campus at Auckland here. And we're working very closely with Leigh and the team at Rocket Lab to take over the operations effectively. So we'll help Leigh and work with Leigh to produce the operations products that are required to actually operate the spacecraft throughout the operational phase of the mission. So Rocket Lab will be operating and producing these initial products, working with ourselves, and around about 6 to 12 months after launch, the idea is that operations will be handed over to the University of Auckland, and we'll be doing that from this room that we're all in here at the moment. So we're setting up this facility. The idea is that it's an enduring national facility that's available for scientific and also commercial organisations as well. And it sits within the Space Institute, which has a number of other facilities to allow us to do the full life cycle of space missions. So alongside the MethaneSAT Mission Operations Centre, we also have clean rooms and National Space Test Facility as well to allow us to test spacecraft and launch them. For the MethaneSAT program, we will build up the capability, both the facilities themselves that we see here, these will be upgraded, but also the staff, and we'll be bringing in, or we have already brought in, some world-class operations people, and we'll be also training up students as we move through. So obviously, the university is an academic organisation, and one of our roles, of course, is to get students involved with this and to train them up. And, you know, getting students involved not just with the academia side of things, but also that hands-on opportunity, I think is really, really important. And it's great for, you know, employers like Leigh and also, you know, NIWA and that, to have our next generation of scientists and engineers come through with some of that hands-on experience. It really allows them to sort of leapfrog into their careers. So that's what we're doing here at the university.
Wonderful, thank you, Chris. All right, so just a reminder, for those of you who are online, if you have any questions, please keep them coming through the chat function. Those of you who are here in the live audience, you'll have an opportunity to ask some questions towards the end. So I'll go back to the speakers now and ask them to dig a little bit deeper into what they covered in their opening remarks, to try and explain, well, why are we doing it, what's important about this mission, what are New Zealand's contributions, and what are the roles of various parties. So I'd like to kick off by going back to Sara. So Sara, could you tell us a little bit about more about methane, why it's important, its impact in the atmosphere, you know, versus those of other greenhouse gases, and why it's important to take early action on reducing anthropogenic methane emissions.
Thanks for that question, Dimitri. Methane is a potent greenhouse gas in the atmosphere. It's emitted from a mixture of both natural sources and human-caused sources. So the natural sources are wetlands and fires and termites to a certain extent, peatlands, those kinds of things. And the human-caused sources are both fossil fuel emissions, and here it's a different type of fossil fuel emission than you think about if you're used to thinking about CO2. It's not so much intentional combustion byproduct. It's a byproduct of leaks and flares in methane infrastructure from the extraction and transport of natural gas, and to a lesser extent coal. So those are the main methane fossil sources, and then it's also produced as a byproduct of agriculture, especially animal agriculture. So cows, sheep, enteric fermentation, and also from rice production. Methane is a shorter-lived greenhouse gas in the atmosphere compared to CO2, which is what you're probably used to thinking about the most. But in its short lifetime, it can have a very big impact on radiation. So how you cost methane compared to CO2, it depends a lot on the time scale you're thinking about. A kilogram of methane that you emit today, if you compare that to the same amount of CO2, over the next 20 years, it has 85 times the impact of CO2. Over the next 100 years, it's only around 30, that number. So, you know, really depends on the type of timescales you're thinking about. One reason that methane's become a big topic of discussion recently is because we've left this so long. We've left tackling climate so long. And by tackling methane now and reducing our emissions of methane now, we can get a fast pulse of slowing. It's a fast handbrake you can put on this runaway train we've got going now for climate change. I'd also like to step back and say, if you're thinking in a longer term, the next decade or so, you have to also keep in mind that there's no pathway to stabilizing climate in the coming decades that doesn't involve CO2 emissions coming to zero. So methane isn't an instead of CO2 thing. It's an in addition to CO2 to slow things more quickly, because we're quickly reaching the point where we'll no longer be able to stabilize climate at the types of levels that people had previously set as targets at 1.5 or 2 degrees. And by reducing methane emissions because of that fast early impact, you're gonna have a higher chance of slowing that climate change in the near term, while you also reduce CO2 emissions as quickly as possible.
Thank you. Now, you've pulled together a team of some of New Zealand's leading scientists for the New Zealand MethaneSAT science program. Can you tell us a bit about what expertise New Zealand contributes to the overall science of MethaneSAT, and why does New Zealand present some good test cases for the capability of the satellite?
Yeah, thanks for that question also. I like to think of New Zealand as being in many ways the perfect test bed for the agricultural research in this project. We've got a really long history of leadership in atmospheric greenhouse gas measurements. We were the first people in the world to start measuring the radioactive isotopes of carbon dioxide. And if you're thinking about remote sensing, there's a network of measurements around the world that look up at the sky in the same way that satellites look down at the Earth. And we are one of 2 founding stations in that network. It's called the TCON network. And that network is really core to being able to validate satellites and being able to ensure their accuracy and calibrate them. So we have a long history of leadership in atmospheric greenhouse gas measurements. And we also have a well-developed modeling capability in New Zealand. So the modeling tools that take you from a concentration of methane in the atmosphere to an emission, which is what you really need if you want to do policy or advocacy. Those modeling tools, inverse modeling, we already have well-developed inverse modeling in New Zealand. And it's actually already being used based on observations on the ground to independently verify the reporting of greenhouse gas emissions that's done in order to meet our obligations under the Paris Climate Agreement as an independent test of those emissions estimates. So we've got the atmospheric modeling measurements capability, the atmospheric modeling capability, and we're also a very nice, clean source of methane, I guess. So our emissions have a very large component from methane. Over 40% of our gross emissions come from methane. So we have high methane emissions, and they're almost all from agriculture. Around 85% of those methane emissions are from agriculture. So if you want a clear story where you can see something you know is going to be agricultural emissions, New Zealand's a great place to look, and we have all of the skills and tools to do the modeling and the ground-based verification in order to be able to know that you've done that problem well.
Wonderful, thank you. So Peter, I'll turn to you. There are a number of satellites either already in orbit or on the drawing boards being planned, scheduled for launch, that are looking at greenhouse gas observation, including methane. So what is unique about this one? What's unique about MethaneSAT?
So good question, Dimitri. A lot of the current satellites observe methane sort of as secondary information. It's one of the many gases they're observing in the atmosphere. And so in doing that, they're not necessarily as precise or as sensitive as we would like them to be to kind of make the measurements that we need to identify where and how much methane is being emitted. And so MethaneSAT is being designed specifically to be tuned to measure methane with both high precision and high sensitivity. In addition, we're also looking to measure not just the amount of methane in the atmosphere, that's what you measure when you look down and you see the reflected sunlight coming back to you, but we're using some very advanced modeling to infer what the emission rate is. So we'll know for different point sources as well as for a global area, how much methane has been emitted into the atmosphere in terms of kilograms or tons per hour, which we can then use to identify the large emitters to go back and target remediation. In many cases, as Leigh pointed out earlier, these emitters, oil and gas fields in particular, don't know that they're emitting methane. They don't know they've got a leak. They have devices in place to mitigate it, but they may be out of maintenance or they may be broken. And so being able to pinpoint where and the amount of emission is helpful to getting them to go and repair those and to be able to reduce the amount of methane that's being emitted in those particular systems. In addition, MethaneSAT is sort of in a sweet spot in terms of how much area on the ground it covers versus resolution. So many of the instruments like Tropomi and other satellites that are scanning the Earth continuously have very wide coverage. They look over 7,000 kilometers on the ground and look at a very large area with very low resolution. So the maps they produce are very, very fuzzy, if you will. Other spacecraft have very small fields of view. They look at a very small area on the ground, maybe a few kilometers in size. It's kind of like looking through a soda straw at the Earth. You can see a very small piece, but you don't see what's sort of around it. So we've designed MethaneSAT to kind of be somewhere in the middle. We have a reasonably good field of view, 200 kilometers on the side. We have very good resolution. So it's a bit like we're Goldilocks. It's just right in terms of the combination of resolution, the field of view, and the sensitivity to measure methane.
Wonderful, thank you. And so my next question is, I mean, you've had a long career working on a number of space missions. From your experience, what are some of the similarities and what are some of the differences between MethaneSAT and what you've worked in the past? And maybe you could talk a little bit about the coalition, the structure, the grouping of partners involved in this particular mission.
Sure. So there certainly are similarities. I mean, the spacecraft itself, as an Earth observing mission, is very similar to missions that have been launched before. It has very similar capabilities, although it's been specifically tuned for methane measurements. But the execution of the mission itself really is unique from top to bottom. First, EDF had to build a team from scratch. I mean, we have no experience in space. A few of the people on our team knew how to spell satellite. So we had to go recruit a team of engineers and managers, most of them driven by a passion for the mission, being able to go and join the team because they wanted to see this mission succeed in order to contribute to reducing greenhouse gas emission. Secondly, everybody on our team is remote. That was even before COVID hit, which is unheard of in the space industry. But you know what, it's working. We've got a great team that's worked together. We've got good relationships. And I think it reflects the partnership approach we have involving all the team members in New Zealand, here in the US, who all have an interest in the mission goals. And then third is we're using the cloud basically for everything on this project. EDF did not want to really invest in infrastructure to do this. And the cloud gives us the flexibility and the agility to be able to perform the operations from essentially anywhere. And so as we brought the team members on board, it was critical to bring New Zealand in. You brought the agricultural perspective, as Sara just alluded to. You've committed to flying the mission for us. EDF did not have a team to fly the mission. So those were both critical pieces of the puzzle to making the mission succeed. And by doing everything in the cloud, the team in New Zealand is able to log in as if they were here in the US or in Europe or anywhere around the globe and can actually operate the mission over the length of the time we're going to be flying. And so that really is trailblazing for this kind of a mission and reflecting the fact that we've got a great working collaboration amongst all the partners, especially those of you in New Zealand.
Oh, thank you, Peter. Well, that provides a great segue into my next question, which is for Leigh. And Leigh, you started talking about this in your introductory comments, but could you dig a little bit deeper into some of the special skills and expertise that Rocket Lab brings to this mission? And maybe talk also a little bit more about how it kind of complements and ties in with the wider range of space activities that the company is involved in.
Sure. Yep. So obviously Rocket Lab is an end-to-end space company, and what do I mean by that? You know, we started with launch, but really, you know, the growth of the space industry over sort of the last 6 or so years in New Zealand has really brought about not just launch, but the rest of the space ecosystem, right? And you know, from a regulatory authority perspective, and actually a lot more of a NASA-esque agency view, which is to enable the growth of the industry and then all the way through from launch. And then you may have noted that Rocket Lab has acquired a couple of companies around the globe which bring components, spacecraft, launch, and now mission operations all together. So when you look at Rocket Lab as a company now, we really go from someone turning up with a payload and saying, hey, we want some data off this at the end of it, right? And to get that data off, you need to build a spacecraft. You need to integrate a payload or a sensor onto a spacecraft. You need to launch that, get it into space. You need to check out that spacecraft, make sure everything is safe and effective. Then you need to operate that spacecraft, and you need to have the ground support networks and the mission operations capability to get data down, and then you deliver that data, right? So you can come to Rocket Lab and say, I want data off this payload, or can you build us a payload and I want this type of data? And you get it all the way to the end and we can deliver you that data, right? So that's what we talk about from an end-to-end space company perspective. And I guess over the course of that sort of 6-year kind of rapid growth, we've established a whole bunch of new capability. And one of those capabilities is mission operations. And so those that have seen it in the media, you've seen us conduct launch, and it's not just the launch that you'll see on the screen and Muriel talking on the live stream, but you'll see the operators that are in mission control, right? So we've got a really good understanding of how space works, right? And how do you monitor the health and telemetry of spacecraft, and how do you remotely upload software to spacecraft? How do you get that data down, and then what do you do with that data, right? So we've got a bunch of, I guess, niche skill sets and infrastructure here in New Zealand, and the people to do so. And that's something that I guess Peter touched on, was that you need smart people doing extraordinary things, and we believe that we've got a lot of those people at Rocket Lab, and that we're the perfect integrator to take this civil government sponsored mission, to bring it through the commercial entity, to hand it to academia, and provide the data to the science community. And that's a really nice, I guess, a nice moulding of being a young space nation, is that we can actually set up, rather than in silos like you would imagine, say the US government has set up, as a government-funded department, and NASA since the 1950s, and then slowly there's been a growth to the commercial industry and agency and academia. And I guess the really cool thing is, and why it's so close to Dimitri's heart, because he was really key to the genesis of this program, but it brings us really tightly together and integrates those potential silos across government, commercial, and academia. So it's a really nice blend, I think. And we're really pleased to be a part of that we can bring our subject matter expertise and to help grow the university, and then in turn, like Chris mentioned, hopefully the product at the end of that is something that we want to take back into our business. And so it's a life cycle. Academia's job is to grow people to go into the workforce, right? That's the role, part of the role of academia, and certainly it's great to be a part of that if we're receiving at the other end. So super exciting.
Thank you, Leigh. Well, look, that probably is a good jump-off point then for my next question for Chris. So Chris, can you tell us what this mission means for Te Pūnaha Ātea, for University of Auckland, to be hosting the mock here, and how this ties in for your plans for your space activities, both on the R&D side and on the academic side?
Yeah, I think it's quite an interesting sort of position that we're in here, because we on one hand have to operate the spacecraft itself for its operational life, which is a number of years. So all the things that Leigh talked about, we have to also build here as well to be able to operate that mission for the next say 5 years. So we need, I'll say quickly, the same sorts of skill sets and that Leigh had, or that Rocket Lab has, and that Leigh's talked about. And we have to have that almost a sort of kind of commercial, say, infrastructure and the facilities like you see in this room. Although, as Peter sort of said, infrastructure's not really the key to it these days. It's really about, say, personal knowledge and experience. And so what we're trying to do here is sort of almost morph between those two sort of worlds, the sort of commercial world, where we have to actually operate a live space mission, and the academic world, where we want to bring through new students and get them out into industry to fuel rocket labs and the scientific community. So it's quite an interesting sort of say a combination or whatever that we have to manage. And so in order to do that, we have some experienced people like myself. I've been in the space industry for 30 odd years, operating and building spacecraft, mainly in Europe. But, so we have some people that are coming in to do that. And we also want to bring students through and actually have them working on this live mission. So on a daily basis, we'll have students in the Mission Operations Centre being able to get involved with hands-on operating a real live, proper space mission. And that really means a lot. And as I say, I've been involved with the space industry for 30 odd years. I've hired loads and loads of people, and having that hands-on experience, Leigh will testify, having someone who can really come through and jump straight into a job really means something. Yes, they need the academic skills, and we're putting together courses and master's courses to provide that knowledge. But having the hands-on skills of actually having live experience, and that combination really, I think, is great for New Zealand, great for New Zealand space industry, and great for New Zealand companies that are involved with the space industry.
Yeah, thank you, Chris. I have to say, I really enjoy coming here every time I come back, sort of see new developments here. The facilities are growing, and really a world-class team coming together here. So it's all very impressive. I wonder maybe just very quickly if you could try and zoom out a little bit and talk about how you sort of see what you're doing here and the MethaneSAT mission sort of contributing to the wider development of the space sector in New Zealand.
Yeah, so I think I mentioned it a little bit earlier, but the Space Institute here has set up a number of facilities, and it's really building on earlier investment that MBIE has put into us. So, the Mission Operations Centre is the latest facility, if you like, that we're putting together, but we also have facilities to build spacecraft and to test spacecraft. We have the National Space Test Facility here, which has thermal vacuum chambers and vibration facilities to test flight hardware before it's launched into space. The Mission Operations Centre is the next step in that, and I say collectively that gives us the sort of full mission life cycle, and we want to be able to offer that to New Zealand industry and New Zealand scientific communities, so that we actually have those capabilities within the country. Previously, organisations would have had to have gone abroad to Australia or the United States or somewhere to do these sorts of tests. So we want to build the capability, and I mentioned earlier, operations is really, built on knowledge, and Leigh sort of mentioned a little bit as well. We need smart people, and you need to sort of have a real system view of the world. You can't go and touch it, you can't go and put a screwdriver in it or soldering iron or something if something goes wrong. So you've got to remotely think about what's happening with the spacecraft based on the telemetry that comes down and the commands that we can send up. And building that experience and that knowledge here at Auckland and making it available for the wider, scientific and industrial community within the country is really what we're trying to do in the Institute.
Great, thank you. Peter, if I could quickly go back to you before we open up to Q&A. I think you've talked about how EDF, obviously not a space mission organisation, had to bring together a team. Are you able to talk a little bit more about the journey that EDF went along, from the initial idea for this mission through to now being preparing the journey towards launch?
Sure. So, everything EDF does in our advocacy is driven by science, data research, and then engaging with other organizations. And so the research our science team was doing at the time was starting to show the importance of methane as a contributor to global warming. We were making field measurements on leaks from natural gas pipelines in cities. Some cities have pipelines with pipes made of clay that are over 100 years old and are cracking and leaking. We also did some field research in the Permian Basin in Texas and New Mexico, where there are a large number of oil and gas wells and production facilities. And that showed too the amount of methane being leaked into the atmosphere. And so we worked with a number of research scientists across the US to sort of develop a concept of how could we measure this and what could we do with the data to turn it into actionable information. And so we started working very closely with the team at Harvard under Steve Wifsey to come up with a plan or a concept of how we might make these measurements. What kinds of pieces of data do we want to derive from the data we might collect? And then if we want to expand the scale beyond the US, we'd had a couple of aircraft flights and made some measurements. We quickly recognized we needed something like a satellite. And so with that, the team really started working closely together through a series of working meetings, trying to sort of decide how should the satellite function. Should it collect data over the entire Earth? Should it look at only special targets like we're currently planning to do? Should it have high resolution, low resolution? And through that process, really refined exactly the kind of mission that would deliver the kind of data we're going to need. In the end, the goal isn't just to collect the data, but to create some action out of that data. And so in addition to building the spacecraft, we're building the data processing pipeline to be able to process the information to generate those emission rates out of the measurements we make. We're also working with our advocacy team to come up with a strategy of how do we take that information out to the public. How do we take it to government organizations who might help us with regulation? And how do we take it to the oil and gas producers who either may not be aware of it or are eager to try to make some adjustments to their emissions to meet their commitments to some of the recent COP26 and other commitments that have been made by oil and gas producers. And so that sort of drove the overall concept. It wasn't a single idea, it wasn't a single point design, but really working with our partners in the science community, working with our potential customers, if you will, in oil and gas, in the regulatory agencies. What is the information they needed in order to be able to do and make the impacts to try to reduce global warming?
Thank you. So look, thank you to our panel members for answering those questions. I'm now going to throw it open to the audience. The live audience, obviously, you can put your hands up and ask a question, and if you're online, please keep those coming through the chat. I'll kick off with one that has come through the chat, probably for Peter, I think this one. So from Yasu, can MethaneSAT detect other greenhouse gases like CO2?
That's actually something we're looking at right now. We have to give credit to our partners at Ball Aerospace as they've been building the instrument and we've been testing it. It's exceeded our expectations in terms of its spectral resolution and sensitivity. And so we've made some measurements which suggest we might be able to make measurements of carbon dioxide as well. We don't want to get too far off of our primary mission objective of methane, so we don't want to spend too much time or energy right now doing it. We want to make sure we can do the primary mission successfully first and foremost. But there is some potential capability there, given how well the instrument's performing, that we can make some CO2 measurements as well.
Okay, thank you. I'll open it to the floor. Please.
Hi. Probably one for Peter. Is how do you make this commercially sustainable? I.e., what's the business model behind it? Are you eventually going to sell the data? Just your thoughts on how it stays sustainable into the future.
So I'll just quickly repeat that for the online audience. The question here is about how do we make this sustainable? What's the business model to make MethaneSAT sustainable?
A really good question. I think we're going to make the data available freely. We are looking to ensure that it gets into the hands of the broadest community possible, scientists and others. The entire mission is funded through philanthropic and foundations and other donors who are looking to ensure we can reduce climate change. And one of the things we've recognized as we've been building this mission is that there's a growing demand from those foundations and philanthropies that are out there to try to make a good impact, to try to find a way to make a measurable impact on climate change long term. And so sustainably, there is a number of folks we've talked with who are interested in contributing additional funding down the road for not only operating MethaneSAT, but possibly future missions that may contribute to helping with climate change.
Yeah, and I might just add to that. I mean, I think MethaneSAT is a very good example of where there is a role for government to contribute. It's probably not the type of mission that the market would necessarily provide, although Having said that, there are companies like GHGSat that are looking at methane remote sensing as commercial services with slightly different instruments. But you know, when you're looking at a public good of this nature, when you are producing actionable data to tackle problems, and of course you're getting science returns from that, I think that creates a very good case for governments to fund these kinds of science missions. I might go back to online chat. So this is there's a tricky question here from Janani, and maybe this is also for Peter, although I don't know if others might want to jump in here. So how will emissions associated with satellite production and operations be offset, and which partner does this? I don't know if anyone wants to have a go
Good
at that one.
question. I mean, actually, one thing we've been doing is part of our work at EDF is tracking the amount of emissions we generate from things like our travel to meetings, how much we're going to be emitting as part of the electricity use, and even how much is going to be emitted as part of the launch to get us into space. And then we're looking at what can we do through carbon offsets and others to ensure that we're contributing to reducing those. And maybe a follow up for Leigh and Chris as well as to sort of how the organizations in New Zealand are handling this.
I think there's a life cycle analysis that you know, as we move towards a more ESG type world, where we're looking at, you know, not just a bottom line and profit, but you know, people, planet, profit, that triple bottom line, that we need to be aware of those emissions in the process of something that is fighting emissions, right? Like it doesn't make, the juice is not worth the squeeze if you're emitting more than you're actually trying to solve, right? But you know, being in an academic institution, I guess, you know, I would hypothesize, or my thesis would be that we would far outstrip the emissions in building a spacecraft and launching that spacecraft, with the learning and the development, and of course the actionable data that we're going to get from this spacecraft to make meaningful change, right? I mean, Sara touched on, you know, the 85 times what CO2, the damage that CO2 can do in that, you know, 0 to 12 years, and that's massive, right? When we think about what that does to the globe, and I've got little kids, and I think, you know, in 30, 40 years, like, do I want the world to be a worse place or a better place? I think we all probably know the answer what we want. But to do that, you know, you've got to accept that there's a cost up front, and the cost up front is to build spacecraft, to launch a spacecraft of this capability, and to get it on orbit, and to spend the money to operate it, and then we get the data down. And it's what we do with that data that's super important, right? And that's why you've got Harvard, Smithsonian, you've got NIWA, to target this. And of course, you know, when it's readily available to the public can do some amazing things, right? And so, you know, we go back to that. Is it a good business model? Well, not necessarily, but is it a public good? You know, has the government sponsored that to be a public good so we can get after stuff? And that's really key, right? Is that we get after this, we get the data at the other end, and then we do something about it.
I'd also just like to put it in a little perspective. The goal of the MethaneSAT mission is to reduce methane emissions from fossil fuels by 45%. So, you know, that's a big goal, and I think and that's before you even get to the potential for agricultural emissions reduction to add to that. So that I would say that the production of the actual physical satellite and operations be very, very small compared to that. It's something I've wrestled with. It's something everyone who works in climate space wrestles, especially anyone who spent a lot of time looking at climate projections and what our future could look like. We all wrestle with that, but I think the case is real clear for MethaneSAT that the good it's going to do will far outweigh any kind of emissions from producing, operating the satellite or the science mission surrounding it.
Yeah, I'd also sort of add that it is something that's been considered throughout the whole life cycle of this program as well, and things like Peter mentioned earlier that MLC or EDF is not wanting to say invest in infrastructure or whatever. So, you know, we're looking at running all the software, and that's being run in the cloud on reusable computers, and we're spinning down those containers or whatever, spinning down those computers effectively when they're not being used between contacts. You know, each contact might be, say, 45 minutes apart or something like that. We get 20 contacts in a day. So, you know, spinning down those computers when they're not being used to save those resources and reduce the amount of energy that's being consumed. And likewise, say, for this facility here, you know, we're looking at reusing these facilities for multiple programs so that we don't have to, say, waste energy or resources, say, in future as well.
Thank you. That's very comprehensive. Any more questions from the audience here?
I guess along the line of sustainability and eco-friendliness, again, this is probably only a small part compared to what good the mission will do, but are there plans to deorbit the satellite just out of interest? Because I know that that is something that is discussed more and more to not leave more behind in space.
So the question here is, what are the plans to deorbit the satellite at the end of life? Peter, I think this is probably your one.
So at the moment, it's got about a 25-year lifetime, so it will deorbit itself, in essence. It will decay. We're launching into a relatively low orbit at 550 and then raising it to 585 kilometers. And so naturally, the current projections show we will deorbit in about 25 years, which is the current guidelines from both NASA and ESA for a spacecraft lifetime.
I should also add, just while we're on the topic of debris, so part of our commitments under the arrangement with EDF, with MethaneSAT, is to take on tracking and collision avoidance, which Rocket Lab is looking at in the initial build of the mock. I mean, Leigh, I don't know if you...
Yeah, so actually partnering with Leo Labs, who, like Dimitri mentioned, have got the Kiwi Space Radar, Central Otago. And so what Leo Labs does is has a commercially available space situational awareness capability or space domain awareness capability, where they're using radars around the globe to track both space debris and obviously spacecraft, both active and inactive. And you could argue that inactive spacecraft are debris or not, but you know, for active spacecraft, we're getting sort of collision avoidance warnings out to about 7 days, and then we've got some limitations around that, around sending commands to the spacecraft to enable its electric propulsion system to maneuver out of the way if we see a collision that is likely. Unlike a chemical propulsion system in space, which creates a lot of thrust, an electric propulsion system doesn't, and so we have to have a company like Leo Labs that can give us enough time to react if there is going to be a collision with another spacecraft. And of course, awesome debris, and the debris can't move, so in that case, your spacecraft would do something, and if it's another spacecraft that's got a propulsion system on board, you would potentially both maneuver to get out of the way of each other. So the collision avoidance is something that, from a sustainability perspective in space, that is particularly important. No one wants to see this runaway effect of collisions and then more collisions and then more collisions, and the more debris you create, the more collisions that there is likely to be, and soon enough you lose an orbit. So 585 Ks, it's not super congested, but it's a good spot to be in, and over the course of that 25 years you would see that spacecraft to deorbit. After 5-10 years, whatever it is, the life of the satellite, that effectively becomes debris, and then you can't necessarily maneuver it. So, we're on to collision avoidance. We've got a really good relationship. We're learning and developing with Leo Labs and looking at the tools that they use. I think they've got 6 radars around the globe now. They're going to have 11 soon enough. So they've got a really great picture, and it's probably not that one, but you can look at Leo Labs online and actually see and touch and feel the movement of that globe, and look at live assets in space. And so it's available free of charge to view. leolabs.org, I think they might be, but they're a great company. They're doing great things, and it's a pleasure to be a partner with them.
So we've only got a few minutes left, so I might just ask the last couple of questions. Sarah, I think the next one probably is for you. So will emissions from landfills be detected?
Yeah, there are some. They're not being specifically planned as a major target at this time, but some of the preliminary results from an airborne version of the MethaneSAT instrument called MethaneAir have shown that you will be able to detect landfill emissions from MethaneSAT.
Wonderful. All right. Look, the last. I think this will be the last question. Any from the room before we? Yeah, please.
So again, this is like a bit further down the line, but what sort of uses are you seeing from the agricultural data? Because a farmer is going to have a herd of cows that are producing methane. Whether or not they know about how much methane is being produced, they still have the herd of cows. So like,
how will the I'll let you repeat the question though.
So I think your question is how will the data from agricultural emissions actually be used? What difference it's going to make?
Yeah, and that's a really good question. It's something that has to be considered with a certain amount of care, because farmers, they're just trying to feed their families. Especially in New Zealand, we'll get a much clearer spatial picture of what our agricultural emissions look like, and some really great independent validation. But also in a lot of parts of the world that the satellite will target, it's the developing world, and people are really just trying to feed their families. And so the picture here is to not just collect these data, but also to link them together through our collaborations with Environmental Defence Fund, and also through New Zealand's activities with the Global Research Alliance and other diplomatic option and policy instruments, to be able to connect this information with mitigation solutions and some support for emissions reductions. Whether that looks like changing the way that we do agriculture to reduce emissions. So there are a number of mitigation solutions that have now been proposed for both animals and for rice agriculture that reduce those emissions, or transitioning the food production in a different direction. I'm not sure, but to link that information right through to someone who can support an emissions reduction operation. I'd say here in New Zealand, it puts us in a really beautiful position to know if we do reduce emissions through something other than reducing our herd, through new technologies to reduce emissions from animals. It puts us in a beautiful position to know we've done it and to be able to prove that it's been implemented correctly, it's working.
Thank you. Well, look, we've hit the hour, so we'll bring this to a close. I hope this has given you a sense of all the exciting developments that are going on in New Zealand, both in our space sector and in our climate change research. It is a really, really exciting time, and I thank you for your interest. Thank you for coming to this presentation. Thank you for joining online. And a huge, huge thank you to our guests, Sara Mikaloff-Fletcher, Leigh Foster, Chris Jackson, and Peter Vedder. Thank you for joining me for this panel. And of course, again, just to repeat my appreciation to Pūnaha Ātea, Auckland Space Institute, for hosting us, and for Rocket Lab for supporting this webinar. So have a good rest of the day, and thank you.